double square roots. Okay, we're gonna sometimes have questions with double square roots. In which case, the idea is still the same. You want to isolate a square root to get rid of it. And sometimes with double square roots, this means you have to do that twice. In this case, we won't, but I'll add a question where we have to do that twice. So, do I have a square root all by itself in this question? I do. I actually have two of them all by themselves, one on one side, one on the other side. So I can start by saying they're already isolated. Let's square both sides. If I square this side, I'm just going to get 2x minus 5. The squaring will get rid of the square root. And if I square this side, I'm going to get x minus 7. How do I solve this? Well, I have some like terms. I'm going to move my x to the left, subtract x on both sides. I'm going to add 5 to both sides, and I get x equals to negative 2. I go to verify my solution. Go to my original equation, 2x minus 5, and oh, I can plug in actually. Let me do that. The answer is negative 2 minus 5, and negative 2 minus 7. So if I simplify both sides, this side's minus 9 and this side is minus 9. They look the same. But what's the problem? Can't square root a negative. This is impossible. So even though we got an answer, we take this answer and put an x through it, and this question has no solution. Do you remember last semester when you had two lines and you had a solution is where those two lines crossed? What I'm going to show you on your graphing calculator right now is I'm going to show you that this makes some graph and this makes another graph. I'm going to take out my calculator, start teaching you how to use some of it a little bit. It's kind of cool. Okay. So I'm going to go to my calculator and I'm going to write the square root of 2x minus 5, because that was our one equation, into the blue one. And into the red one, I'm going to do the square root of x minus 7. And I'm going to hit graph, and it's going to graph the blue one, and it's going to graph the red one. We have the blue one here, the red one there. I kind of want to see, looks like they're going further to the right. Kind of makes sense because you can't square the negative. It makes sense that the smallest number we could put into the green one, which happens to be the red one, is a 7. Anything less than 7, you'll get square roots of negatives. So one thing you can do on your graphing calculator is you can change your window and say, I want to see more. So right now my window goes from x values of minus 10 to 10. What happens if I went up to 100? And I graphed it. Now it shows more of the graph. You see that the red graph and the blue graph are not intersecting. I go to my window and say, I now want to go up to 1,000. And maybe I need to see higher. Maybe I make my y values up to 100. And I graph. Does it look like they're ever going to cross each other? No. And if two graphs never intersect, they never have a solution. So this is sort of connecting to what you did with lines, right? You graph two lines if they intersected. Remember if you had two parallel lines, then you'd have no solution? So we sometimes have different shapes of graphs. They also might not intersect. So this is an example of getting an extraneous root. So you can circle question 10.